Hello and welcome to the second in our series of videos on Azure Enterprise Integration. This is part 2 covering the Azure Resource Manager. My name is Dan Probert. I'm the Chief Technical Officer at Aphanis. You can find me on Twitter at ProbertDaniel, and I have a blog at www.bizbert.com. Just recapping, this series is intended for developers, testers, operations and support staff, technical managers, architects and designers, and pretty much anyone else with a bit of technical knowledge and curiosity. There are 12 videos in this series. The first video was on challenges in enterprise integration development in Azure. This video, part 2, covers the Azure Resource Manager. Each video is about 20 minutes long. The other 10 videos are listed below, and you'll be able to find links to each of the videos in the description for this video. The Azure Resource Manager, or ARM, is the deployment engine behind Azure. Basically, we supply it a description of what we want, and ARM goes away and provisions it. So we can say create a number of VMs and their hard disks and virtual networks and a number of other resources, and ARM will go away and make sure that they exist. ARM gives us a flexibility to group resources how we want. Because we supply a file to the ARM engine with a list of the resources we want to create, this file is known as an ARM template, we can put in that ARM template either all the resources we want or just the ones we want to create at that time. That means that we're not creating resources independently of each other, one after another. We can say, here are the resources we want to create, and keep them all in one location. Each resource to be created is identified by a provider. So for example, for a Logic app, that would be Microsoft.logic/workflows, and an API version. The API version specifies the exact type of resource that you want to create. Some resource types have multiple versions, as Microsoft will release newer versions over time. This allows you to stay within compatibility. For example, if you're used to using an older version of a resource and Microsoft have released a new version, then your ARM template can dictate that you still want to create the older version. The Azure Resource Manager is also the engine behind the portal. When you create a new resource in the portal, what's going on in the background is that the code in the portal is making REST calls to ARM to create those resources. So there's no magic. If you're creating an ARM template and deploying it, say, from PowerShell or from Visual Studio, it's exactly the same engine that the portal is using as well. Right, let's talk a little bit about resource groups and what they are. So a resource group is a mechanism of grouping resources in Azure. There should be a clue in the name there. This provides an ability to apply actions and properties across all the resources in your resource group. So for example, if you're using RBAC, role-based access control, to control access to your resources, by applying that at the resource group level, you're applying the same permissions across all the resources. So if you give user A contributor access to a resource group, they by default also have contributor access to all resources in that resource group. A resource group also acts as a billing container, so you can see the costs of all the resources in your group as a whole. It rolls up the costs for you. Now when you're deciding what resources should go into a resource group, the main rule of thumb is that resources that share the same deployment lifecycle should be grouped in the same resource group. And there are some exceptions to that rule, which we'll cover in the next slide. Another thing to remember is that resource groups also have a location. Now this location is just used for the resource group metadata. There's actually no limitation on where your resources in a resource group are located. So you could have a resource group that is located in North Europe, which contains some resources that are in West Europe and other resources in Southeast Asia. The general rule is that you should keep all resources in the same location as the resource group unless you have a compelling need to change them. For example, you're doing disaster recovery. Right, if I show you a quick demo of resource group creation. Right, in the dashboard here, if I come up to my list of resource groups, I'll see a collection of resource groups here. Now, one thing I'm just going to point out now, and we'll cover this in a video later in the series, is about naming of resources. If you don't put your environment name in your resources, then as you get more and more resources showed in your list, it can be difficult to group them or determine which environment each resource is for. So we have a naming convention that we will share later on where we group and put the name of the environment in the resource group name or in the resource name, and that allows us to see immediately which resources are for which environments. So this resource group I have here, if I open this up, I will see I have a number of resources in here. I have an app service plan, some logic apps, service bus namespace, and an app service. Now all of these resources are for the same demo application. They share the same deployment lifecycle, and I can tear these down if necessary as a whole. When I create a new resource group, it's going to ask me for a name and also a location. As mentioned, this location is just where the metadata for the resource group is stored. It's not necessarily where the resources in the resource group are going to be located. So how do we choose which resources should go in a resource group? Here's some rules of thumb. Resources that are used exclusively by the same application should be in the same resource group. If I have a customer information service and I have a number of logic apps and API apps and SQL Azure database that make up that application, they should all be in the same resource group because they will share the same deployment lifecycle. If I'm tearing down the application, I'm tearing down all parts of the application at the same time. However, if any resources used by an application are shared with other applications, they should not be in the same resource group. They should be grouped with any other resources that are shared and used by those same applications. So, if I have a common database that is used by 5 applications, it should be in its own resource group. And if there was an API app that was used by those same 5 applications, it should be in the same resource group as well. If you're going to end up with a whole lot of resources on their own in a resource group because they're only used by a subset of applications and no other subset of applications uses the same resources, you should look at creating a common resource group and grouping those applications together. There's an exception here because then you're not grouping them together by the deployment lifecycle, but you're also then not allowing lots of resource groups with a single resource in them. Another recommendation is to use resource groups to delineate application environments. For example, have a resource group for the development version of an application, one for the test version of an application, and so on. You might also have separate subscriptions, so you might have a production subscription and a non-production subscription. But within those subscriptions, you should still be using resource groups to delineate environments. For larger applications where you have many resources, it might make sense to split the application further into multiple resource groups. So for example, if you have a whole lot of resources around the front end of an application, for example websites and mobile apps and the like, you might put those in one resource group, and then you might put middleware and database resources in another resource group. Now in this case here, although you have split them, they still share the same deployment lifecycle. It's just that you now need to tear down both resource groups when you are tearing down the application. We have an example of why these resource grouping rules are important. Let's assume I have a customer services application. It's all together. We've put the resources in a resource group called resource group A, and in there we have a logic app, an API app, a function app, and an Azure SQL Server. Now if I need to tear down this application, I can tear down this resource group. I can redeploy it, I can make changes to it as a whole, and it doesn't affect anyone else. Now let's say that 6 months later you end up with 2 separate applications, a web app and a mobile app, who for some reason end up using the same Azure SQL Server instance that's in resource group A. So now we have resource group B with a web app that's using the Azure SQL Server instance, and we have resource group C that has a mobile app that's using the Azure SQL Server instance. Now in this example, the web app and the mobile app are unrelated to the application that's in resource group A, and they're not sharing the same data as resource group A, they're just using the same resource, in this case here in Azure SQL Server. Now, what happens if I tear down resource group A? If I tear down resource group A because I have to redeploy the application, for example, I break the web app and mobile app that are in the other resource groups. So this is why it's very important that you look at how your resources are used and you group them in resource groups accordingly. In this case here, as soon as we discovered that we had other resources that were using the Azure SQL Server, the Azure SQL Server should have been moved out into its own resource group, a shared resource group. Let's talk about ARM templates. As we spoke before, ARM is the engine for performing deployments in Azure, and we pass ARM a list of resources we want to create, and the way we do that is with ARM templates. So an ARM template is a JSON file that specifies the resources that we want ARM to provision for us. An ARM template is a complete template language. It's got functions and expressions as well as the JSON language behind it. Inside an ARM template, and we'll cover this in the next slide, we have parameters, variables, resources, and outputs. Each ARM template contains the resources for a single resource group only. This is very important. You can't have resources for multiple resource groups in the same ARM template. However, you can split an application up into multiple ARM templates. For example, you could have an ARM template for logic apps and one for databases, etc. So, although you can't have a single ARM template containing resources for multiple resource groups, you can have a single resource group being made up of multiple ARM templates. So an empty ARM template looks like this. It's a JSON file with a schema, it's got a content version, and then it has 4 sections: parameters, variables, resources, and outputs. Parameters are values that we pass into the template, anything we don't want to hard code. So often that will be the name or the ID of resources that change between environments. Remember, the beauty of an ARM template is that we can create it once and we can use it for different environments. So if we have a logic app, for example, that we deploy to a development environment, and then we want to deploy that same logic app to a test environment, it's the same ARM template, and we use parameters to change any values that change between environments. We can also use parameters for secure values, so for example connection strings or shared access keys or passwords that we don't want to hard code. Variables are values that we create during the deployment process, so things that we aren't passing in but that we want to create either based on parameter values or functions or expressions inside the template. Resources are the things that we're actually creating, and we showed that earlier with a resource type. So for example, a logic app is an example of a resource that we might want to create. And outputs are any values we want to return. Now let's go through these 4 sections one by one. So parameters. These are values that we shouldn't hard code. So for example, they're either application specific or maybe they're secure values. And there's an example here of a parameter that's called logic app name. That's the name of the parameter. It's of type string. It's got to be between 1 and 80 characters in length, and we have a bit of metadata there. If you want more details on the parameter values you can set, you'll find those in the further reading section, which is at the end of this presentation. Now a parameter can also contain default values. If it's got a default value, that makes the parameter optional, so you don't need to supply a value for it. If it doesn't have a default value, then at the time you execute the ARM template, it will ask you to provide a value for the parameter, and if you don't, it will raise an exception. It's up to the developer to define what parameters are needed. So some designers, for example the logic app designer, will create some parameters for you. But ultimately during the design phase, the architects and developers should define what parameters are going to be needed. And the reason for this is that parameterization is a crucial part of integration development. Once you have created an ARM template, either in the portal or in Visual Studio, you need to go through and pull out any hard-coded values or any values that would change during deployment time. And we do that so that we can automate the deployment of these resources. So for example, passing in the ID of any resources that we're using, or any resource group names or application names that change per environment. ARM template variables are values that need to be created at deployment time. They're usually formed from a combination of parameter values and expressions or functions. And one of the prime use cases for variables is that instead of having to hard code a long value, you can put it in one place in your variable and then refer to it multiple times. So for example, if you've got an ID to another resource, an ID in an ARM template is pretty much similar to a URL. Instead of having to put that, say, 4 times throughout your ARM template, you can declare it once in your variable and then reference it multiple times. The beauty of ARM variables is that you can also use them with expressions, and that reduces the number of parameters that you need. So for example, here we're building up the ID to a Logic App integration account, and it's combined of a number of values: the subscription ID, a resource group name that the integration account is in, and the integration account name. Now, without using functions here, or expressions, in this case here the subscription function, we would have to pass in the subscription ID as a parameter. But in this case here, we can build this up once and then reference that in our ARM template. Resources in an ARM template are the actual resources that you want to deploy, so the ones that you want the ARM engine to provision for you. Each resource has a name, a type, a location, a version, and properties. For example, in what we see below, name of the resource we want to create, the type of resource, which is based upon a provider. We'll be covering this in the next slide. The location for the resource. Remember, this doesn't have to be the same as the resource group location, but the recommendation is that it is. Any tags that we want. This is metadata that we tag our resource with. The specific version of the resource. So in this case here, we've got an example version of 2016-06-01. Any properties for the resource. So this is actually where most of the data is. So for a virtual machine, the properties will consist of the disks and the disks and the name and the virtual network interfaces that the virtual machine would need. And for a Logic App, for example, the entire definition of the Logic App is in that properties section. Interestingly, you can actually have resources that are children of other resources as well. So you can have sub-resources. And then the Depends On section at the end lists any resources that need to be deployed before this resource can be deployed. If the Depends On section is empty, then the Azure Resource Manager will deploy things in parallel, but otherwise it would deploy them in sequence. So as mentioned, for Logic Apps, the entire Logic App definition is in the Properties section. For example, if you're in Visual Studio and you're in the Logic Apps Designer and you switch to Code View, everything you see in there is actually located in that Properties section, that Properties tag. And as mentioned earlier, the Depends On tag is used to indicate that the resource is dependent on other resources that must be defined in the same ARM template, and that we won't deploy this resource until the other resources have been deployed. And you can see a full list of providers in the portal via the Resource Explorer. Let's have a look at that. So if we come up here and we go to More Services and we start typing resource, we'll get the Resource Explorer. If we open this up, this lets us look at all the resources that are deployed in our subscription, or it lets us also see all the providers. So if I open this up, here you see all the providers that are available. Now, not all providers are available in all regions. If I come down to Microsoft.logic, which is where Logic Apps are, I can see these are all the different types of resources that can be deployed. So we have workflows, integration accounts, locations, and operations. Opening up integration accounts, we can see these are the locations where you can deploy a Logic app, and these are the supported versions of Logic apps that we can deploy. So 2016-06-01 is the current version, but you could, in theory, deploy an older version of the Logic App engine if you've got an older version of a Logic app you want to deploy. It's worth going through the list of providers here to understand just how much you can create in Azure and understand how they all work. And the last part in an ARM template is the output section. And this is used to return information back to the calling process. So an example would be if you were creating a service bus namespace and you wanted to return back the connection string for that namespace. So the example you see here is we're returning a namespace connection string, and we're using a combination of expressions and functions to look up the primary connection string for the service bus namespace we created in our template. ARM template parameter files. Now, this is just a mechanism for grouping parameters for an ARM template together. It's a JSON file that contains one parameter for each required parameter in an ARM template. And you can have multiple files for different environments. So for example, you might have one file for dev, one file for test, one file for UAT, which all have the same parameter names in them but different values. We'll talk more about that later when we get to our video on deploying from deploying from Visual Studio and then deploying from Visual Studio Team Services, because you have a number of choices here. Although you can use parameter files for your different environments, you can also use parameter overrides. Or you might decide to have a single parameter file. You might decide to have a parameter file that just has the name of your environment in it, and then use variables in your ARM template to build up the names of the resources. But what we see down here is an example parameter file that's got a single parameter in it. The name of the parameter is Logic App Name, and the value is my Logic App. Now, deploying ARM templates. There's multiple ways to deploy an ARM template. One way is via the Resource Explorer, or you could do it via PowerShell, or you could do it via the REST API. Those are just three of the ways of doing it. There are more ways. Deployments are named and execute asynchronously. So when you submit a deployment, you give it a name and you'll give them back a tracking ID, and then you can make subsequent calls to the management API for ARM to find out what status your deployment is in. So is it still deploying, or has it succeeded, or has it failed? You can also deploy in full or incremental mode. This is very important. When you deploy in full mode, what happens is the ARM engine will effectively tear down your resource group and then just deploy what's in your ARM template. So if you had 5 Logic apps that were already in your resource group, and then your ARM template only had 3 Logic apps in it, you'd end up with 3 Logic apps in your resource group. Incremental mode means just change what is changed in the ARM template. So to use the previous example, if I had 5 Logic apps in my resource group and I gave it an ARM template with 3 Logic apps, as long as those 3 Logic apps are the same as 3 of the 5, then I'll end up with 5 Logic apps. If they were new Logic apps, then I'd end up with 8 Logic apps. So it looks at what's in the resource group and compares it to what's in your ARM template and makes changes to make sure that what's in the ARM template matches what's in the resource group. But if you have resources in your resource group that aren't in the ARM template, it doesn't touch them. And within an ARM template, resources with no dependencies are deployed in parallel, whilst those that have a dependency are deployed in sequence. An example of using the PowerShell commandlet is using the new Azure RM Resource Group Deployment commandlet, and we pass it in the name of a deployment. That can be any name as long as it's unique. The name of the resource group that we're deploying to. We have to make sure that resource group exists already, because it will not be created as part of this commandlet. We pass in the full path to the ARM template file, and then we pass in a parameter file as well. Now we can also override parameters by passing a list of parameters directly on the command line here for the commandlet. How do we obtain an ARM template sample? So say you're building up a collection of ARM templates. How do you actually get an example ARM template? For example, how do we get one for a storage account or a service bus namespace? There's a number of ways we can do that. We can use the Resource Explorer. There's the website to the Resource Explorer. It requires you to log in using your Azure subscription credentials. You can get it from the portal using the automation script option, which I'll show in a second. You can use it, get it via PowerShell commandlets, and also there's a REST API, the ARM Management API, you can use to query and obtain either a full ARM template or even an example ARM template. So I'll show you an example now of how we could use the portal to get a full ARM template. So if I come back to my list of resource groups, I come in here and I see I have a number of resources already in this resource group. There's an option over here called Automation Script. And I can click on that, and what it will do is it'll go away and generate the ARM template for all the resources in that resource group. Now what you've got to remember is not all resources are supported today in the Automation Script option. So for example, what it's saying here is that it can't export resources of type Microsoft.web/sites/config. So it hasn't included those resources, but every other resource is in here. So I have an app service plan. If we come down here, we'll see we've got a number of parameters. We have a logic app. We have a service bus namespace. We've got a server farm, which is an app service plan, and an app service inside there as well. And then we have some authorization rules as well. So we can then select everything in here, and we could copy and paste that into Visual Studio if we wanted. Now you can also drill down into the individual resources inside a resource group, for example, and export those templates as well. So if you want further reading on the ARM template language and how you can manually author resource group templates or ARM templates, these two links will help. So the first one is about authoring templates, and the second one covers all the functions and expressions you can use in a template. You should really read these resources if you're doing integration development, because as you'll see when we come to Visual Studio, there are a large number of Azure resources that don't have a designer. So for example, if you want to create a service bus namespace with topics and subscription rules, you can't create that directly in Visual Studio. You'll either need to export it from the portal and paste it into Visual Studio, or you'll have to write it manually in Visual Studio. There's no designer, there's no visual designer that will create the template for you today. So for that reason, it's imperative that you understand everything you can do in an ARM template and how they hold together. Right, that's the end of part 2 in this 12-part series of videos. The next video is going to be part 3, talking about Visual Studio and project types. We hope you've enjoyed today's video, and look out for the next video. When it's available, the link to it will be available in the description for this video. Thank you for watching.